we're going to learn about sensors today, and there are two sensors I chose. One is the proximity sensors, which I just introduced, measures the distance. The other one is a vision sensor. It basically tells you, you can think of it like a color sensor. It tells you intensity of a red, green, blue, and you can use any combination. It will tell you basically what is the red and green and blue content in the signal. So I'm going to demonstrate how this works. And what I'm thought of doing was I'll put two blocks there, cuboids, as you can see on the screen, and I'll put a proximity sensor, I'll put a vision sensor, and I'll show you what readings these sensors get. I'll show that through a graph. Okay, it's easy to visualize, and then I'll show you how to get it in the script, because once we get it in the script, we can then use that information to control a system, like for example, a car or a manipulator. Okay, so let's get started. First, create objects. So let's cuboids. So primitive shape, cuboids, and I'm just going to make it same size. So 0.5, 0.5, 0.5. So that shows up there. Let me call that box 1. Okay, and then I'll need another one. So I'll just copy that and paste it. And that's box 2. So that's actually sitting on top of box 1. I need to move that. So I'm going to select translation and move along, let's say, so you can see this axis. So we have X, Y, Z. I want to move it along Z axis. So I'm just going to so I'm going to move it along the Y axis. I'm going to just check mark Y and move it. And then I want to maybe move this one slightly to the left. Now, if you want to have a better visualization of this and you want to put them in some orientation, what I suggest to you is to use this view. You can see this view here. It basically, if you click that, it tells you the different views which are available. Okay, and maybe I want to use this view to shift them, right? It's much easier in this view. So top view. So here we have the same boxes. I'm going to now adjust this. We just move that, let's say here, and then choose other box and move it here. So it's not really important in this example, but I thought I should just show this to you. Okay, so move those boxes, done. Let's change the view again, click that, change to this view. Change to, sorry, this view, the original view. Okay, now let's generate a sensor. Let's start with proximity because I think it's much easier. So add proximity sensor, and it tells you different types of sensors. This just is the same sensor, but just the type of ray it shoots. Some of these sensors will have straight beams. Some of them would have a beam which would be sort of like a triangle, and some of them would be like a cone, and so on. If you want a better idea on how these sensors look, then I would suggest just searching for proximity sensor in CoppeliaSim. I think this is an introduction to the sensors. So this is a cone type, but see this one. Okay, here it is. Ray type, cylinder type, cone type. So it does the same thing, but essentially the kind of coverage area depends on the type of sensor used. So I wouldn't be too much worried about it. But the reason they provided this is that, you know, sometimes you buy a robotic system has a particular sensor and you want to reproduce that system. It might be a cone type, so you want to use a cone type proximity instead of using a ray type. So ray type is actually this one, which is a straight line. Okay, so let me move that. Let me add a proximity sensor, just choose ray type. Okay, and then you don't see it because it's put somewhere in the ground because it's at 0, 0, 0. So I'm going to just move it here. Okay, now what you see here is that this sensor, I need to move it slightly up because you can barely see the axis of on the sensor. So let's move along Z. Okay, now it's better. So now what you see is, you see the sensor, you see this red, green, and blue for the sensor. That's the rotation frame for that particular sensor. Okay, if you want them, you can use it to rotate the object. So what I'm going to do is I'm going to actually rotate the object only because right now, as the sensor is pointing, it's actually pointing in the sky. It's looking at the sky. I actually wanted to look at the box. So I need to rotate the sensor by a certain angle. So how do you figure out the angle? You have two options here. You can rotate about the world axis, or you can rotate about the parent axis. So what I'm going to do is I'm going to rotate about the world axis. So if you see here alpha, beta, gamma, this is basically the, in the language of rotation, this is going to be rotation about x, Euler y, Euler z. Okay. Here, they don't really tell you the order, but it really doesn't matter what representation they use. So I'm going to rotate it about, let's see, if I rotate it about, well, you can see there's a y-axis. It looks like I need to rotate about y-axis. And if I rotate about 90 degrees in the positive y-axis, it'll actually point towards the positive x-axis. So you can do that by imagining your thumb pointing along the green, and then the direction which your fingers curl gives you the direction to move. So that is not what I want. I want it to turn minus 90 degrees, because then it will be pointing towards the box. So you can actually do it that way, the way I told you, or you can just start playing with the numbers to see if it gives you what you actually need, right? So that is now pointing towards the object. Okay, you got that. Let's try to create a graph, because we want to see what that output is, what the proximity sense is reading. So next step is add graph. Okay, let's put it to the bottom left so it doesn't really interfere. Next, let's choose what we want the graph to show. So add new data stream. And we have these options, and some of these options we've seen, rotation, position X, Y, but here we are interested in the proximity option. So let's try to get the distance. So I will choose proximity sensor detect distance. Okay. And then it's only showing proximity sensor because it's the only sensor which gives me the distance. So, okay. And then let's say distance. And then let me change the color in preparation for the second part. Let me make it green. And then if you think this is too small for you to see what really the proximity sensor looks like, it's basically a sphere which you can change. Okay, so you can double click on that and then tell the visualization to change to a bigger size sphere. So I made it 0.05, so now you can see it's much bigger. So it might be easier for you to think about when it's bigger. Okay, so now what I'm going to do is I'm going to run the code, or rather the simulation. And I was hoping to see that I would see some distance here, but there's nothing coming up. Okay, and that's because uh, the sensor is actually blind to the box, and that's because I've not told the simulation that you're allowed to detect the box, and that can be is a property of the box, which is somewhere in the box options. If you see this, there are these special properties, which is, do you want the object to be colliding with other objects? Do you want it to be measured? Do you want it to be detectable, renderable? In this case, what we need to do is we need to make it detectable. And when you choose this, actually you can choose what sensor you want to allow it to be detected. Okay, here I just chose all of them. So there are many types of proximity sensors. I just showed you in that video ultrasonic, but there are other proximity sensors which you can use. Okay, the type is really immaterial in the simulation. Okay, so we did that, and now let's run this. And it said still there is nothing coming up. Okay, so I think this is something to do with the sensor now. Let me open the sensor. So there is the sensor is a range. Okay, and I have chosen 0.5, but let me just make it 1 meter, so the sensor can read 1 meter. So when I did that, you saw that this red line actually increased. So that is basically the distance the sensor can measure without any issues. Okay, so let's do that and now run this. Oh, well, it doesn't run either. Okay. Okay, there was a suggestion that's hitting the box. It's not. Okay, let me try to move it and see if things change. So let me move it along X. Nope. So the sensor is actually far away. it's not hitting the box. Let me try to move it along the y-axis. Oh, there it is. So actually, I think it was not. Okay, so actually the sensor was outside. Okay, so this is really hard to see in this view. Let me change the view. Okay, let me change it to top view. Okay, now you can see this is where the problem is. I think maybe one of you suggested this, but thanks for the suggestion. The sensor is actually not looking at the box. It was kind of not in the view of the box. So what I need to do in this case is translate the sensor. So take this and move it. And now when it hits the box is when you see that the distance is actually showing up. So the distance about 0.57, it's almost constant, right? Because it's not, well, there are significant digits, that's why it's coming from. But if you move it, again, you have no data. And then if you move it there, it actually stopped because I have not set this box to show. Okay, let me just change that first quickly. I need to go here in the settings, go to common, and then make it detectable. Okay, now go back to this, change the view to this one, and then move the sensor. There it is. There it is. Okay, if you can move it closer along the x-axis, remove y, you can see that it actually is decreasing the distance. It's going to 0.2, and then when I increase it, so it's actually showing me 0.8 or something like that. Okay, so that works. Okay, so that's how you read the distance. Now let's see how to do this in code. Okay, how do you get this data in code? So I'm going to try to create a script. So script, insert new script. Let me call it non-threaded. Okay, and then open it again, and then associate it with whatever you like. Let's say proximity sensor. It's not very important. Okay, so now in this code, what I'm going to do is, this is the usual thing, which is I'm going to figure out let me get the handles for the different things here. Proximity equals sim dot get object handle, and I'll write it at proximity, but I need to change that in the code. So I wrote this proximity, but it's not called proximity. There should be, let me call this proximity, so it's easier to write it. Proximity. Okay, so once I do that, now this will make sense. And then I also need box one, a handle for box one. So get for box one, and do the same thing for box two. Okay, got that. Now let's see how to read the sensor. For that, I need to go to the CoppeliaSim API. So CoppeliaSim API. And then I need to search for proximity. Okay, read proximity sensor. That's what I want. So there is this Lua synopsis, which is what I need. Okay, I'm just going to take that, copy it into my code. And here you can see actuation sensing. So I'll put it in the sensing code. That way it is all there. This is a really large, well, it's a lot of things. So get rid of the number because that's just giving information on what is generated. The table 3 means that detect point will give you a table of 3 numbers. Okay, that's all it means. So it's like an array. And then move this. And then table 3. So these are all the pieces of information which are coming back. The distance, detected point, detected object handle. So in this case, it would be the box 1 or box 2, and then surface normal. So many of these things I'm not interested, but I'll just keep them there. And then I need to put the sensor handle. So I need to put the proximity handle here because that's the sensor. So let me put this. And all I need to do now is just read the distance. So print So let's stop this, run that. Now it's not in view. You can see that it's printing nil. That means that sensor is not detecting the object. So let me move this along, say in this case, y-axis. Okay, so you can see it's reading 0.375. The same thing is reported here, which makes it make sense. Now we can move it here, and now it's not being detected. Let's go to the top view. It'll be easier to see. Okay, so move it. Nothing's detected. And then when we go back, we can again see it's 0.375. Let's move it along x. And see it's decreasing. So the same values are reported here, so which is good. So let's stop this. Okay, now I have 5 minutes. I'm going to quickly show you how to do the vision sensor. Okay, so let's generate a vision sensor. So add vision sensor, and there are two options. You can choose either of them, doesn't really matter. Again, you can read the manual about what these sensors do. So we got the vision sensor, it's buried. Let's move it out. And okay, there it is. And let's move it along the x-axis now. There, and then move it down a little bit. Okay, it looks tiny. So what I'm going to do is I'm going to actually make it bigger that we can see. Now the way they show the vision sensor is actually a cuboid, so 0.05, 0.05. Okay, that's better. Now it's pointing in the sky. I want to rotate it, so I'm going to go to rotation and then do the same thing, rotate by minus 90 degrees, same logic as previous. So now it's shooting there. Now, the easiest way for me to show you is this sensor is that it actually takes red, green, blue. So I'm going to change the color of this to red and the other one to blue, and then you can see the data which comes out. So I'm going to change the texture, sorry, change the adjust color. Yeah, it's adjust color. So let's make that red, and then go here and then adjust color and make that blue. Okay, and now since we got that, let's another element to the graph, add new data. So in this case, let's add, so you can see these are all the vision sensor data. What we want to do here is I would try to get the average red value. So that's for the vision sensor. Okay, and let me call that just red so it's easier to see. And then add new data stream, and we'll call that vision sensor, but we'll get the average blue value. Okay, it's not working for me. Let's see if it works now. Average blue value. Okay, that works. And let me call that blue so it's easier to see. And also change the line type to blue. Let's call that blue. So it's easier to correlate then. Okay, so we got that. Let's close it. One thing which I should do, and this is something I showed you earlier, is you need to ensure that you can detect this object. So that option for a vision sensor is called renderable. Okay, common renderable. Okay, done. So now let us essentially play this. Okay, so you see nothing coming here. You should actually have seen some. So the distance sensor will not give you anything because it's not seeing directly pointed towards red, but we expected something from the vision sensor. It's not because it's not in view. So I'm going to move it now, X and Y. Move it. Oh, vision sensor. Okay, let's move this now. Okay, so now you can see. Okay, let's see now. Okay, something's not right. So I believe that's because I did not choose the object. I think I need to choose the volume here. Uh, Perspective mode. Okay, you just choose that and see if that works. Okay. I was not expecting this. It's getting the signals from the vision sensor, and that was, as somebody noted in the chat, it was the rescaling problem. The moment I removed the proximity sensor from the view, the vision sensor worked fine. So here the blue is the vision sensor, the red is the proximity sensor. So we've already done proximity. I'm going to focus on the vision sensor. So you can see that the vision sensor is outputting, well, I've made it so that the red intensity is red color in the graph and blue intensity is blue. And so since this vision sensor is in front of a blue box, you can see that the blue signal is 0.6 or something, and the red signal is way down. It's actually close to 0. Now what I can do is I can actually move this sensor. Okay, let's see. Let me choose the vision sensor and then move it along X and Y. And so let's see, I'm going to move it. And now it is not facing anything. And so you can see that the blue has dropped. Just going to, it's actually hidden behind this. But you can see it here, it's dropped from 0.6 and the red one has increased. And that's because it's actually seeing a black screen. You can't quite see what it's seeing there, but it's actually seeing the sort of the environment, which is totally black. Okay, it's going to show up in some time. But then you can keep, well, okay, there it is. Okay. Okay, so now let's me just move this further and move it in front of the red. Okay, now you can see that the red has spiked up and the blue has gone down, just reversed of what we had seen earlier, right? And so that is showing how the sensor works. Essentially, you can use this fact to trigger or detect colors. Okay, now I'm going to show you something what might be very interesting to see. That is, what exactly is the sensor seeing? And we can actually see what it is seeing through what is known as a floating view. So I'm going to close this. I'm going to right click and say add a floating view. Okay. And I'm going to make this floating view correspond to what the sensor is actually seeing. And so the way to do it is, once you've created the floating view, click on vision sensor. So it's already highlighted. Okay. Now right click on floating view and say add, let's see, say view and say associated view with selected vision sensor, which means that this sensor is now going to show me what this view is going to show me what the vision sensor is seeing. And so now let me run this. Okay, so now you can see, well, let me just move it down. Okay, so you can see something blue. That's because this sensor is seeing the blue box. Let me translate the sensor and move it back. Okay, so this is what the sensor is seeing. It's seeing the blue box, it's seeing the ground, which is sort of brownish, and then the black thing is the environment behind it. And so let's just move it and see what's going on. Let's move it. And you can see it's now going to see the red box a little bit. If you move it closer, the red box disappears because it's too close. And then you can just move it to the red box and you can see the red box. So this is how the vision sensor is working. It's actually seeing the box just like a camera would see in the environment in front of it. Okay. Sometimes it's good to have this view so that you can understand what the sensor is seeing. If you want to have multiple views, like here I just have a projection of 2D view, you can actually do that. So if you actually right click and say add a floating view, and let me see if I get this right. Will you say view selector? Let's say I want this view. So you can see now you have two views, which is the top view, but also the side view. So now we can run this. let's move it down. And so you can now visualize how things are in this. So let me move this again. Okay, so you can see that the sensor is moving in the 3D view. Now, if you want to change the perspective view over here, what you need to do is the following. I'm going to stop this first. Okay, let's just move this down permanently. Okay, so now the issue with this view is that you cannot rotate this view like the way you rotate this. So what you need to do is you need to swap these two first. So what I'll do is I'll just click twice on the this default camera. So I'll click on this, and then you see that the views have got swapped. Now what I can do is I can actually rotate it the way I want. So I'm going to rotate this view using the tools here. So rotation. And then a little bit of translation. So maybe I want it this way. Okay. And now if you want to go back, then you just double click on the default Z view camera to that it's got swapped. And now you run this. And so now you can again do the same thing, which is translate the sensor. And then you can see how the sensor is moving in this default camera view on the left. So that's just a handy thing for in case you want to have multiple views. Okay, let's stop. Okay, the last part which I need to talk, and I think this is very important, is how to take the data in Lua script, because if we can do that, then we can then use that data to write a controller to do things, right? So I'm going to just rename this just to simplify my object handler. Let me call this just vision enter. Okay, then open the script. Okay, and this is the script which I wrote down earlier for proximity. So I'm just going to comment out this one, which is basically taking the data from the proximity sensor and instead write the code for the vision sensor. So I'll introduce a new handle for the vision sensor. So get object, and since it's called vision, I'll just say vision. So we got the handle. Now I need to find the right code to get the data from the vision sensor. So what I'll do is again go to CoppeliaSim to API. In the API, I'll search for vision. Okay. So vision reset. I don't want any of these. I need to somehow read the vision sensor. So let me see if there's a corresponding command. Get vision. No. Oh, there it is. Read vision sensor. Let me click that. Okay, so this is the synopsis. We are interested in the Lua script. So the syntax we need to use is num result, table, auxiliary value packet, so on and so forth. So let's just copy this and then we'll try to understand what's going on. Let's copy this and paste it in our code. Okay, so paste it right here. It's really long. Okay, so what this is saying is basically is that this is the first output is a result. And actually, if you go to the documentation, it's basically will be either you detect something or don't detect. So it will either be 1 or it'll be nil. Okay. The second one is a table. Okay. So table, think of table as a array. Okay. So it'll give a list of variables. Now, how many variables will this auxiliary value packet produce? Well, we can look at the documentation here. So here it says table auxiliary value packet 1. There's no information here. Well, it's right here. So it's the same as the C function. Okay. So the C function is here, and it basically tells me that the aux values are 15 auxiliary values, the minimum. And what are those 15 numbers? Well, first is the minimum of intensity, red, green, blue, depth value. That means be the minimum intensity, minimum red, minimum green, minimum, and so on. So that those are 5, I believe. Yeah, 5. Then the maximum of intensity, red, green. So the next 5 are the maximums. After that, we have average. So we have intensity, red, green, blue, depth value. So that's the 15 ones. 5 for min, 5 for max, and 5 for average. Okay. And the best way to learn about them is to actually see them through a graph, or get the data and see what they're doing. I don't think they're going to be a whole lot different. If you use any of them, I think you should be just fine. So I like to use average. So I'm going to use average, red, green, blue. Okay, because those are the ones which I think make sense in this case, where we have either a red object or a blue object. Okay, so that's the aux value, but then there's more, the aux value packet 2, 3, and so it turns out that the additional ones, you can specify any number, are are additional things which you specify. Let's not deal with that. So that's maybe for some other video. So we'll only get the first two, the first one being the result here, and the second one being the aux val packet. That gives us all the information we need. So we'll delete the rest of it. So let's go back to the script and get rid of this. And we're left with only with the first aux packet, and you can call it anything you want. So if you want, I can call it data vision. Okay? And then the vision sensor handle, which we've defined as vision. So what this does, as I said, it's going to produce 15 variables. Okay, we only are interested in some of those, and I said let's stick with let's say the average. So average is average. Here it is, average of intensity red, green, blue. So let's choose average red, average green, average blue, and that should be, well, see, so we have to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 11, 12, 13 are the data packets I need. So let me just put a comment before I forget. 11, 12, 13 is average red, green, blue. Okay, so now we're ready. So we'll say print data vision 11, data vision 12, data vision 13. Okay, I think we are set. Let's see if this produces the output as we see. So okay, this is slightly hard to read, but I hope you can see there's a comma here. There's a comma there. That means this is the first value we are outputting, the red average red value, average green value, and average blue value. Now, this has to correlate with this graphs, right? Because that's also plotting the average values. So if you see the first average value, well, it's 0.25, and here for the red, it looks like it's less than 0.1. I suspect that's because I'm actually not using the average value. Let's see if that's the case. So what I'll do is I'll stop this, go back to graph, and that's the average red value. That is in fact the red value, and this is the average blue value. So there seems to be a discrepancy. Okay, let's run this again. Huh, 0.25. That doesn't look like 0.25. And the blue is 0.6. I think I made a mistake somewhere in my data package. Let me just go back. So here it is, 15, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So it's be 12, 13, 14. I think I made a mistake there. Let me stop this. So it should be 12, 13, and 14. Okay. So 12, 13, and 14. Okay, let's see if this works. Okay, there it is, 0.086, and that looks like it's less than 0.1, so that might well be 0.8. The green one is not plotted here, so don't go by this. This is for the proximity sensor, and the last one is 0.61 for the blue. So that looks about right. Now let's move this sensor. So translation, and let's move the sensor along. I need to move the vision sensor, so select that and then move it. Okay, now you can see that the red is about zero 0.6. So the first one is actually about 0.6, 0.63. The green is almost unchanged, 0.1, and then the blue has shifted down to zero 0.1. So that looks good. That agrees with this. So that means that the sensor reading is working. Okay.